In this video, I'm going to cover practice questions for grade 12 general. These are the focused IPQs for the end of term 2 exam. It's all about circuits. Okay, starting from the beginning over here, we have a charge and we have a time. We need the current. Charge is Q, time is T, current is I. Q, I, and T. You will check your formula sheet, have a look, and we have one somewhere. Check the formula sheet and you will notice that there is a formula relating these three things together. That is quit. Q equals IT. I call it quit. I need to find I. I can do shift solve or I can rearrange. I'm going to rearrange. I equals, I will divide both sides by T. Q divided by T. I have students who rearrange these wrong. Many. Please don't rearrange incorrectly. If you can't rearrange, go ahead and do shift solve. It's fine. You'll get the answer. You'll get the marks anyway. So 5 divided by 0.05. 0.05. Putting that into my calculator, I will get 100. 100. Now, hold on a second. What's all this? Well, obviously it's not 8, and obviously it's not 2.5. It's either one of these two. What does this mean? This is simple. Times 10, 2 times. 1 times 10, 2 times is 100. 1 times 10 times 10, that is 100. This means times 10 twice. This means divide by 10 once, divide by 10 twice, and so on. You can literally put that in your calculator. You'll get 100. If you do 1 times 10 to the 2, you'll get 100. Just a little clarification in case you're confused by that. Now, for electrical components, we need to find a switch and a variable resistor. So which of these is a switch and a variable resistor? Well, I'm going to just show you everything. You should know them all. This here is a simple resistor. That's a resistor. I'll write it out. Resistor. Terrible writing. I'm not going to write it. That's embarrassing. I'll call it R. Resistor. This is a resistor with an arrow. The arrow tells me I can choose the value. It's a variable resistor. I can change the value of my R. And this is the American way. The British way is like this. This is like a resistor. Or you could have it like this with an arrow as well, like this. That's the British resistors. This is the American resistors. What's this? This is a switch. It's a drawbridge. You can switch it on, switch it off just by moving the bridge. That's my switch. And finally, this here, this little S shape is considered as a fuse. That's a fuse. Now, the fuse can look like this, and of course, the British way, it will look like this. I have shown you both methods, both ways in my class, but it looks like they're sticking with the American ways. So make sure you're okay with these. So what am I looking for? A switch is C, and the variable resistor is B. The answer, this one here. So now we know. Let's move on. In this one, we're comparing wires. Like I said to you, there is a formula relating to them. The actual formula is R equals rho L over A, and we don't actually need to use it. We just need to compare lengths and areas. I've made a video talking about this, so you can go back and check it. I use a little animation. But for now, we'll go ahead and solve it. Long story short, longer area, not longer area, doesn't make sense. A longer wire, this will have more resistance. Longer wire has more resistance. So much longer, because the electrons have to travel further. They lose more energy. And a bigger area has less resistance. There's more space for them to travel. So a bigger area has less resistance. If they're trying to squeeze through a tight little hole, it is hard for them. There'll be a traffic jam trying to get through. But if they have a bigger area, they have more space to go through, there will not be a traffic jam. So in this case, our relationship, I am looking for the difference between the L's and the A's. This rho, resistivity, this is the material, the strength of the wire. It's all the same wire, all at the same temperature. This doesn't even change. I'll consider that as 1. As I've showed you before, I normally do 1 times 1 divided by 1 and then see what happens and compare them. I'll do the same thing. To speed things up, I'm not going to write this 1 here. That's going to be the same for all of them. So I'm going to ignore this. I'm just going to do the L over A. I'm going to compare for A. Let's check A out. A, I'm going to do L divided by A. So that's simply just 1 divided by 1. That's just going to give me 1. There's no change here. This one is 2L over A. 2L divided by 1. That will give me 2. This one over here, I have L, which is just 1. 2A, 1 divided by 2, well, that's a half, 0.5. 0.5. And this one over here is D. This is 2L divided by 2A. 2 over 2, that is 1. So all I did was I divided L by A for each of them. Once I did that, I can see which one has the greatest resistance, the biggest number. B has the greatest resistance. And it makes sense because it's the longest, thinnest wire. The least resistance will be the shortest, thickest wire, which would have been C in this case. There you go. Next, you're asking to find current with watts, that's a power, and ohms is a resistance. This is I, this is P, and this is R. We have three formulas to choose from. We have PIV, P equals IV. We have PIR, P equals I squared R. This is a combination of PIV and Ohm's law, V equals IR. And then we also have P equals V squared over R, which is still another combination of Ohm's law. These are the three power formulas. There is another one, PIT, that involves energy. So that one's a little bit different. That has energy involved. So if I wanted to find power, I can use PIT. But these are the three that we're going to use if we have this. What do we have? R and I can use the second one. I'll do P equals I squared R. I can shift solve and get the answer or rearrange. Shift solve is easy for everyone, so you can do that, but I'm going to rearrange for those who want to try. So that means I'll take the R to the other side. I'll do P divided by R. P divided by R equals to I squared. I don't want I squared, I want I, so I will take the square root of this. This is what I will do. Anyway, you can put the numbers in directly, so let's do that here. Square root of P, which is 5, divided by R, which is 220. And just so you know, you can just do it like this. 5 equals I, which will be my X, squared multiplied by 220. It's the same thing, okay? It's the same idea. Putting this in your calculator, you will get the value for your current. Let's find out what that value for the current is. You should hopefully get around 0.15 amps. Don't forget the units. Okay. In this case now, we're trying to find the energy in this. So energy is the PIT formula, PIT. We rearrange that. So this PIT, I can take the T to the other side and I will multiply it. So this will be E equals P multiplied by time. Slight problem, I don't have P. I can find it. I have a voltage, I have a time, okay, that'll be good for my T. And then I have a resistance, R, V and R. I need power. What can I do? I can find power first. I can do this. I can first do P equals V squared over R. I can do V squared over R, 60 squared. I'm going to divide that by 30. And then you can just times it by 4 at the end, but I'm separating it out. I'm finding the power now. This is my power. 60 squared divided by 30, I should get 120. 120 watts. That will help me. So this is my power that I'm going to use right here. I'm going to substitute that into here now. I'll find it now. 120, multiply that by my time, which was 4 seconds. 120 times 4. If you're a math whiz like me, you will not need a calculator for it. 480. 12 times 4. 48. Add the 0. 480. Just use a calculator, whatever. Anyway, joules is the unit. Very nice. So we're able to do that. Now let's move on to this as a series circuit. You know it's a series circuit because they are in the same path. I have made many videos on circuits, series and parallel, and practice questions for other grade levels. If you want to revise more, please check them out. This is just the focus questions, so this is reduced number of questions. So I will go through them and try to explain as much as I can. In a series circuit, there is only one path. Each electron has to go through all three resistors. To find the total resistance in series, you add them, R1 plus R2. I just did a little quiz with one of my classes and they mixed the formulas up for series and parallel, getting everything wrong. So please don't mix these up. Series is one path, you add the resistors together. So adding them, 7.5 plus 11, so I'll write it here, 7.5 plus 11 plus 25, or it's 2.5 even, that's supposed to be a plus. And that will equal to, now actually I don't even need to do the addition because clearly these are totally wrong. It has to be 21. I can verify that to check with a calculator, and it is 21. Good. It's the only number that makes sense, to be honest. So it will be 21. Very nice. In this case, you want to find the current, so this is just like this, but with an extra step. Now I need to add the resistors, and then do Ohm's law. So let's find our total first. I will add them. I'm not going to write the formula out. I'll do 5 plus 2 plus 1 plus 2. Well, that is nice and simple. 5 plus 2 is 7, plus 1 is 8, 9, 10. The total resistance is 10 ohms. Now I can find the current, by the way. We know the formula, Ohm's law. The general equation is written like V equals IR. This is the most famous circuit equation that you should know. Everybody should know this. I will be V over R. I will divide. Some people do I as V times R. They don't rearrange properly. Please be careful with the rearranging. I can't stress it enough. When it comes to the end of term exam, we don't want these small problems because you don't want to lose marks for nothing. So be very careful. Do shift solve if you can't rearrange. I is V over R. We will do 20, divide that by 10. 20 divided by 10 is 2. The answer directly, we have C. The answer is 2. Okay, let's move on. Over here, another series circuit. So if we want to find the voltage across the 5 ohm resistor, you can do. We can do Ohm's law twice, or we can use a voltage divider. I'm going to show you both ways. I like to use a voltage divider. That's useful if you have a voltage and 2 resistors in series. Or if 3 resistors, it doesn't matter. A voltage and resistors. You don't have a current? No problem. We will use a voltage divider formula. That's the V out. The V that I'm looking for is my battery voltage, V input, the battery voltage, multiplied by my ratio of the resistor that I want over the total resistance. So they are sharing the 90 volts. This 90 will be shared between them. And it becomes a ratio. This is half of this, so there will be a little ratio over here. My prediction is this will have a third of the total current, because that's 5 over 15. And let's find out. 90 multiplied by R that I'm looking for is 5, divided by the R total, 10 plus 5 is 15. That's a third. 5 over 15. 90 times a third is directly 30 volts. And that means this has 30 volts, which makes sense, 30 volts, because this one will be 60 volts. How do I know that? Well, this is double this, so double the voltage makes sense. And does it also make sense with the battery? 60 plus 30 is 90. That does make sense. Obviously, this question is only asking for this one. In the exam, I might ask you for something else. So we have used this little voltage divider to check and get the answer. And we make sure it makes sense. If you add the two, you will get the battery. There's a Ohm's law method that you can do. You can find the voltage by doing V equals IR. The problem with that is you need to do, I'll change the color actually, because this is a different method. You can do V equals IR. The problem is we don't have I. You can solve for I though. V over R. I total is the V total over R total. So you can find the total current. You know the current is flowing through both resistors. This is just an extra. You can skip this, by the way. But this for those of you who want to try the other way to check your answer. V total is 90 over 15. 90 divided by 15, 90 over 15, of course, is 6. The current is 6 amps. I can use that now in both of these. I can do V equals IR. For the first one, I could do I, which is 6, and I'll multiply that by 5. 6 times 5 is 30. So my answer is the same, 30 volts. I can do the same here. 6 times 10. 6 times 10 is 60 volts. This is also correct. So now you know 2 ways to solve it. Let's go back to the teacher color. Okay, what is the reading on V1? So there's 2 ways to do this one as well. You can see that now this is double of this. You can safely assume that this will also be double of this. They're directly proportional with each other. The voltage and the resistance is directly proportional to each other. Bigger resistance means bigger voltage. How do I know that? Is V equals IR. Big R means big V. That's it. But we can check. You can find the current flowing through here and then do V equals IR like I did before. You can do it. Let's check. Let's do I equals V over R. This was the blue method above. We can do 80 divided by 20. Now, why am I not using the full battery supply? Is because I know this 80, I know this is 20. I can find the current flowing through here, which means it will be the same current flowing through here. It's one current. 8 over 2 is 4 amps. Now, if I wanted to find V1, I can go ahead and do it. I can do V equals IR. Same current passes through, 4, multiplied by the resistance, which is 40. 4 times 4 is 16, add the 0, 160 volts. So that makes sense. Very good. Now we can move on and see this one here. We need to find the voltage across R2. That is, R1 is 16, R2 is 14, and we have a battery 15 volts. So in this case, I will use my method that I like, is the V out formula. V out equals V in R over R total. R total. V in is my 15 volts, and I'm going to multiply that, don't need that V, multiply that by, the R I need, R2, 14, not 16, 14 divided by the total. 16 plus 14 is 30. 14 over 30. So I'll do 15 times, and I'm going to do the bracket, not the bracket, the fraction, 14 over 30, and I will get 7 volts. 7 volts. Done. I have 7 for this one here. You can do 15 minus 7. If this one, which one was this? Sorry, this is R2. This is 7 volts. I could do 15 minus 7. 15 minus 7, of course, is 8. This would have 8 volts. Does it make sense? Yes, it does. These two add up to 15. This is smaller, 7 volts. This is a little bit bigger, 8 volts. Makes sense. I will stop there now, and I will continue in another video. Thank you.